Okay, so in this next video what we're going to do is look at the way by which phosphatidylinositol 4,5-bisphosphate can actually be regenerated in the membrane, and how IP3 is broken down and then how it's put through that regenerative pathway. So at the moment what we've seen is how PIP2 is broken down and into IP3 and diacylglycerol, or diacylglyceride, they're the same thing. So now let's have a look at the breakdown of IP3. So let's draw our IP3 here, and I might draw its skeletal structure to speed things up rather than its full molecular structure. So skeletal structure, basically corners denote carbons, and whenever you don't show hydrogens, basically. So if there's missing bonds, then you just assume that they're bonded to hydrogen, and that's what the spare bond is. Other than that, you show everything. So what we'll need to do is show all of the hydroxyl groups, like so. But we won't show all of the hydrogens or the carbons, basically. Oh dear, and I've actually missed off the phosphate groups. Now, where should I draw the phosphate groups? So we need a phosphate group off here to make IP3. So here's our phosphate group off the first oxygen. Then we've got another hydroxyl here, and we'll have our phosphate groups off here. Okay, so we're nearly there. And then our final one off here. So this is the structure of inositol 1,4,5-trisphosphate, so IP3. Right. Okay, so the steps in the degradation of this are that there is an enzyme which removes this phosphate group from the second hydroxyl group. So there's a dephosphatase, well, or just a phosphatase enzyme, which removes this specifically this phosphate group, the phosphate group on the 5th carbon, if you like. So IP3 is inositol 1,4,5. So let me just write it out. Inositol 1,4,5-trisphosphate. 1,4,5-trisphosphate. So basically you have a phosphate group of carbon 1, a phosphate group of carbon 4, and a phosphate group of carbon 5. And basically the first one that you need to remove is this phosphate group of carbon 5. So that goes first, and that reduces you down to inositol 1,4-bisphosphate, or IP2. So this is inositol 1,4-bisphosphate. Okay, right, so let me draw that out. So that's a 6-carbon molecule again. And all you've done basically is remove that phosphate group off the 5th carbon. So, like so. And then we've got this phosphate group here, so this one's remained, this one's survived the phosphatase. It's going soon though. This has now been reduced back to a hydroxyl group. This is still obviously a hydroxyl group. A hydroxyl group still here, hydroxyl group here, and then a phosphate group here. Okay. Right, now, the next step, oh, and I should have finished that, that's a phosphatase enzyme that does that. The next step is that you remove one of these phosphate groups, and now the molecule is completely symmetric, so it's arbitrary which one you remove now. But a phosphatase enzyme, again, is going to come and do this, and these are different phosphatase enzymes that do these different steps, basically. So another phosphatase is going to remove the next phosphate group, and then you're just going to end up with inositol phosphate. And this time you don't need a number, because obviously it's completely rotationally symmetric. Inositol phosphate. Okay, right. So that's just inositol bonded to a single phosphate group. Okay, so I'll draw this again. So here's our 6-carbon ring. And now you have 5 hydroxyl groups, and only a single hydroxyl group is still bonded with that phosphate group. And we'll, for the sake of the picture, we'll make it this one here. But as far as which one was actually removed in this stage, it could have been this one, it could have been this one. It's the molecule doesn't know that we've labelled this one 4 and this one, sorry, the enzyme doesn't know that we've labelled this one 1 and this one 4. As far as it's concerned, that molecule is exactly the same whichever way you look at it. Okay, so hydroxyl O-. So there's our phosphate group, that's inositol phosphate, and then there's a final phosphatase which removes the final phosphate group off. And this transformation now that breaks inositol phosphate down into pure inositol, this is quite an interesting one, because there is a drug which specifically blocks that phosphatase that removes the final phosphate group and returns you from inositol phosphate to pure inositol. And it's basically a single ion. It's lithium. Lithium ions block this enzyme that removes that final phosphate group in this process. And if you block that enzyme, then you cannot go through the degradation process for IP3 properly. So this is a lithium ion here, so the lithium cation. So what does that mean? Well, you still degrade your IP3 down to IP, or inositol phosphate. So you terminate the signal, and I should have said that actually, I should have stressed that big style, that as soon as you've removed this first phosphate group and gone to inositol 1,4-bisphosphate, it becomes useless. This molecule is not capable of stimulating the IP3 receptor, so this one degrades the signal. Now, the rest of them are important in actually rejuvenating your PIP2. So if you inhibit this enzyme by taking lithium cations, then what will happen is that you're not going to be able to regenerate PIP2, and what's going to happen is that gradually you're going to lose all of your phosphoinositide signaling, and basically lithium can be used to treat bipolar depression, and it is reasonably effective at it. And it's thought that this action on this phosphatase and removing the PIP2 signaling may be important in its treatment of manic depression. Okay, right. So inositol then. What do we do with inositol now? So how are we going to use inositol to regenerate PIP2? Well, basically what we do is we take a phosphatidate molecule and we bind inositol to it. So the next reaction is basically the production of phosphatidyl inositol. So basically we take in inositol and we also take in a phosphatidyl or a phosphatidate molecule, so just a normal phospholipid, phosphatidate. And let me just remind you of the structure of phosphatidate. So again, you have this glycerol molecule like so, and then off this one you have this phosphate group, so it's a phospholipid, remember, so off the third or first carbon, whichever way you view it, you have this, a third carbon would be the general, more conventional way. You have this phosphate group, and then hydrogens off the rest of there, and then off this second carbon you have your long-chain carboxylic acid esterified here, and off this first carbon you have another long-chain carboxylic acid esterified off here, like so. Okay, so this is phosphatidate, and basically when you combine that with inositol, what you're going to get is phosphatidyl inositol, or PI, phosphatidyl inositol. Right, so this is this molecule here. And shall I draw the, I'll draw the skeletal structure. In fact, no, I will draw the skeletal structure for this. So the skeletal structure for propane is just to have 1, 2, 3 carbons. So that denotes these 3 carbons here. Right, off here we'll have this hydroxyl group coming like that. And then we'll have our we'll have to put our phosphate group all on there, like so. Oh, I need to, it's obviously phosphatidyl inositol now, so you're attaching your inositol in here, like so. So there's your 6 carbon ring, and then you'll put the hydroxyls in on every single carbon, like so. Okay, so that's the inositol bonded to our phosphatidyl, and then just to make these look, complete these bits down here, this is our second carbon. We've got an oxygen there, and we've got our long-chain carboxylic acid esterified to it, and then we'll draw the same thing here. Okay, so that's a slightly, it's a slightly easier way to draw it maybe. It takes slightly less time. Okay, so phosphatidyl inositol would often be abbreviated as just PI for phosphatidyl inositol. Right, okay, and then what you do is you first phosphorylate this fourth hydroxyl group here to create phosphatidyl inositol 4-phosphate. So you then phosphorylate it to create phosphatidyl inositol 4-phosphate. Inositol 4-phosphate. So you put a phosphate group in on this fourth hydroxyl group, but you haven't yet put one in on the fifth phosphate carbon either as well. So phosphatidyl inositol 4-phosphate would just be denoted phosphatidyl inositol and then a single phosphate. And then finally what you do is you add in the next phosphate group onto that second one to create phosphatidyl inositol 4,5-bisphosphate back, or PIP2. Okay, right. So that's the way in which you rejuvenate phosphatidyl inositol 4,5-bisphosphate from the IP3, basically.